Hi everyone, this is Ms. Tom with lesson 9.2.1, graphing two variable inequalities. So our goal is to be able to graph inequalities, but first what we're going to do is we're going to go ahead and graph this part right here, negative 2x plus 3. Couple of reminders with this, anytime you're graphing, it's always important to notice the y-intercept. So we're going to notice the y-intercept, and the y-intercept is here, 3. Remember we called it 0, 3, the y-intercept. And the y-intercept is located where? Well, remember we're going to highlight the y-axis. And where is it located? It's located at 0, 3. Where is 0, 3? 0, 3 is here. Then the next thing is if we look at the slope, or the rise over run, and you're going to notice that the slope is negative 2. So what are we doing there? Negative 2 is the same thing as negative 2 over 1, which means you go down 2 over 1. So once again, negative 2 means down 2 over 1. So what we're going to do is from the y-intercept, we're going to go down 1, 2, and then over 1, 1. So then we're going to be right here. Once again, negative 2 as our slope means down 2, 1, 2, over 1. You're always going to the right 1. All right, and then if you want to go the other direction, you're just going to do the opposite, up 2 over 1. So it's kind of like a little stairs, up 2 over 1, up 2 over 1. And then connect your points, and you've got your line. All right, so it says, is the point negative 1, 5 a solution to the equation? How can you tell? Well, we look at the point negative 1, 5. Where's negative 1, 5? Negative 1, 5 is here. Is that a solution? We say yes. Why is it a solution? It's a solution because it's on the line. Yes, the point is on the line. Now, let's go ahead and talk about this one. Is 2, negative 1 a solution? So let's look, 2, negative 1. 2, negative 1, that's going to be right here, and 2, negative 1 is also a solution. So we're going to say yes. 2, negative 1 is also on the line. So we notice it's also on the line, so those two are solutions. Now let's go ahead and ask ourselves, what about 9, 0? Is 9, 0 considered a solution? And we'd say no, because it's not on the line. So what determines if a point lies on the line? What is the difference between points on the line and points not on the line? Well, points on the line have to follow what? They have to follow this equation, y is equal to negative 2x plus 3. It needs to be able to make true statements with this line. If it makes true statements with that line, then you're good. That's solid. If it doesn't, then it's not. All right? So now what we're going to do is we're going to do a little bit of an exploration activity. All right? And here's our exploration activity. What's going to happen is I'm going to have you guys choose any point you'd like, and I want you to see if it makes the inequality true. For example, let's go ahead and choose the point 0, 1, okay? If we choose the point 0, 1, and this is going to be our x value, and this is going to be our y value, let's see if this makes a true statement, okay? Because by the end of class, you should be able to graph inequalities like this. So we're going to put 1 here, the inequality symbol, negative 2, but instead of x, we are putting in 0 because it's there. Then we're going to ask ourselves, does this make a true statement? Let's see. 1 inequality here. Negative 2 times 0. Oh, negative 2 times 0, that's just going to be 0. So we've got 0 here, plus 3. Then we've got 1 is greater than or equal to 3. Is this a true statement? We'd say no, not true. So is 0, 1 a part of the solution? We would say no, it's not a part of the solution. So we know this is not correct. Okay, but let's choose another point. Let's choose another point. Let's maybe say 1, 5. All right, so let's test this one, where we'd say this is our x value and this is our y value. Okay, so then what we're going to do is let's go ahead and put in those values. We'll put in y for 5. The inequality is still there with greater than or equal to. Okay, so then we have negative 2, but instead of x, we are putting in 1. And then we'll say plus 3. And what I want you to notice is we put 5 here. Inequality, is this true? This is going to be negative 2 plus 3. Negative 2 plus 3 is going to be 1. Is 5 greater than or equal to 1? We say yes, it is true. Since it is true, what is a solution to this inequality? A solution to this inequality is going to be 1, 5. So this means that it works out. This means that it's true. It's a point on the inequality that makes it true. So what I want you guys to do right now is I want you to pause the video and test out random numbers. Test out random numbers that you come out with, see which ones are true and which ones are false. I'm actually going to work on that too right now. So everybody, we're going to pause the video together and see what happens. Alright, so hopefully you kind of just tested out random points. You don't have to choose any points that I have chosen. You just choose a random point. And when I mean random point, I just thought of, okay, I'm over here, I'm looking at this part right now. Everybody, let's look at the left-hand side. I just chose the point -1, -6, just randomly. I decided, is this a solution? I don't know. Let's test it. Is this right? So then what happened is I replaced x with -1. That's why you see it here. And I replaced -6 with y, which is here. Then I solved the calculation and I noticed this is not true, which means this point is not a solution to this inequality, meaning it doesn't work. So then I tested 210, and again, this is random. I just chose this point, 210. Okay, it's a random point, so let me see if it works. And I noticed it is true. So that means that 210 is a solution to this inequality. And then I proceeded to test a bunch of other points. Now, I again really want you to try it out. If we were to do this in class, all the students would have chosen random points and figured out which ones are true and which ones are false. So what's going on is you're going to be looking at which ones are true. So 1, 5, okay? 1, 5 is a true point. Is 0, 1 a true point? No. 1, 5 is a true point. So on this graph, I've already graphed -2x plus 3, okay? Also, I want everybody to notice that it is a solid line. We're going to talk about that in just a second. It's a solid line. And then we're going to go back to, what point did we say? We were testing out 1, 5. Where is 1, 5? Because it's a solution, we're going to actually graph it. 1, 5, that's here. All right? Then I'm going to test the other points. What are the other points? -6 or -1, 6 did not work. But then we're going to graph 2, 10. Why? Because it's a true solution. So let's test that. 2, 10. Where's 2, 10? 2, 10 is here. All right. And let's see, what else can we test? We also can see that, oh, -2, 8 is considered a solution. Okay, so let's look at -2, 8. -2, 8 is going to be -2, 8. That's here. Okay, and if you were to test a bunch of solutions, you're going to start to notice something. You're going to start to notice that all the solutions are appearing where? Above the line or below the line. So if we were to do this in class, what we notice is that all the students would end up putting their points here because these are the only thing that creates solutions. If you were to test any of these points here, you'd notice they are not solutions, and that's why it doesn't work. So all the solutions happen to be here that make the inequality a true statement. So again, all the students would have tested points here, and you would have noticed if you would have tested points, all these points end up working. So how do you say, okay, those are all the solutions? What you do is you'd be like, oh, those are all the solutions? That's why the solutions to this inequality are going to be everything above the line. So once again, everything above the line. So what you get to do is you get to do some coloring and you get to shade. So you get to shade everything above the line. All right? And that's what it means to be a solution to the inequality. Now, earlier I mentioned that notice how the line was solid. The reason why the line is solid is because if we look at the inequality, which is located here, notice what about this symbol right here? We've got an equal to symbol. So, looking here, what do you think this one would be? This is the same graph, but it's not above the line, it's below the line. So we have the inequality y, we have -2x plus 3. It's the same one here, but instead of it being greater than, the inequality is going to be not greater than or equal to, it's going to be less than or equal to. Why is that? Because the solutions are below the line. So did you see how over here in the previous one, the inequality is greater than, that's why it's above, and then this one is below, so that's why it's less than. So once again, this is less than or equal to. So then the next part is we determine boundary, solid or negative. So which ones are considered solid, which ones are considered dashed. Dash meaning it's not equal to. So all the ones that are solid are going to be the ones that are equal to, meaning this one and this one. So these guys are going to be solid lines. And what I mean by solid line, I mean that the inequality has a line that has no dots. Whereas a dashed line looks like this. That means that the solution does not include those points on the line. So I know that was kind of confusing. Don't worry, the more we practice with this, we will actually understand it more. But the main thing is I want you guys to understand that the inequalities that are dashed, they don't have the equal to symbol on the bottom because the solutions cannot equal to that point. But what I really want us to notice is where do you shade? So right now, again, I'd like you to pause the video and then graph this line. All right, hopefully you paused the video. Then what happened is you should have graphed all these points, the y-intercept being -1. We go, the slope is -1 over 3, which means down 1 over to the right 3. So you guys can see that I went down 1 over 3, down 1 over 3, down 1 over 3. Make sure you've paused the video so you can test it. Next thing I want you to notice is that with this inequality, this guy means, is it dashed or is it solid? This guy means that it's dashed, meaning the solutions are not on the line. So I'm going to use my dash tool here and connect the points using the dash tool. So kind of not solid, not that. I want to do dashed. So let's see if this will work. Maybe this will work here. There we go. A dashed line like that, except I didn't do that very well. Okay, so it has a dashed line that looks like that. Now what we want to do is we want to determine, where do we shade? Do we shade above the line or below the line? That's the question. Do we shade above the line or below the line? Well, we're going to test a point, and it's really important to test one that's above. The easiest one to test above is 0, 0 or 0, 1. So I'm going to test, is this a solution? Is 1, 1 a solution? So I'm going to put 1, 1 here. Actually, better yet, you know what the easiest one? 1, 1's not even the easiest. The easiest one is actually 0, 0. If you test 0, 0, that's actually the easiest. Like this guy right here. If you test 0, 0, and you're going to see, does it make a true statement? You test, does it make a true statement? Let's find out. So right here, I'm going to draw a line. Instead of x, we're going to put in 0. Instead of y, we're going to put in 0. We go 0 greater than -1/3. Instead of x, we're going to put a 0 minus 1. So then we get 0 is greater than, that's 0, -1, 0 greater than -1. Is this a true statement? Is 0 greater than -1? And we would say, yes, it's true. So that means that 0, 0 is a solution. So that point is about the right place to shade. So we're probably going to shade above. But it's always good just to double check. Just to double check, hey, is that actually a solution? So you know what I'm going to do is I'm going to test this point right here. I'm going to test, let's go with, I want to do something that's like a divisible by 3. So I'm going to do this one right here. I'm going to test this point. -3, -6. Okay, so again, what are we doing here? We're going to put in x here and a y here, where we're going to put -6. Is that greater than -1/3 with the -3 for x? Then the -1. So we're going to notice -1/3 of -3. Okay, so that's going to be -3 over -3 minus 1. Then we've got this here. Alright, and then we go test -6. Is that going to be greater than, well, -3 over 3 is 1. 1 minus 1 is 0. Is -6 greater than 0? We'd say no. This is not true. So we just proved that this point -3, -6 is not a solution. So where do we shade? Since that one is not a solution, that's not what we want. Instead, what we're going to do is we're going to shade above. Why? Because 0, 0 ended up working out. So 0, 0 ended up working out, meaning everything on this side gets shaded Why? Because those are all solutions to the inequality. So now your job is to test them out. I'm not going to go over everything so slowly like that, but what I want to do is I want you to test it. I'm going to show the solutions in just a moment, but again, test it out for yourself. Pause the video, and then we'll meet back and see, did you get the same solutions as me? All right, welcome back, you guys. Hopefully you graphed it and have some idea. So I want to point out a couple of things. So I graphed it. It's a solid line. Why is it a solid line? Because of this part right here. That line makes it so that you know this is a solid line. Then I also wrote down our slope being 4 up, 1 over, and I tested a point. I'm always going to test the point 0, 0. Why? Because 0, 0 is super easy. You put in x for 0, you put in y for 0, and then you see, does it make a true statement? When I did that, it does make a true statement. That means that this point is a solution to the inequality. Then what I do is I test a point on the other side. So you know how it's on like below? I test this point, and this time I tested -3, 0. I tested that point, and I noticed that is not true. Since it's not true, we can't shade that part. So this one can't be shaded. So we're like, no, I'm not going to throw shade that way. I'm going to throw shade below the line. So that means we're drawing that these are where the solutions are. So that's where you will be shading, and I'm going to actually use a highlighter for that. This is what we're shading because 0, 0 ends up working out. Okay, again, over here, we're looking here. This is a dashed line. Why is this considered a dashed line? It's considered a dashed line because it says the inequality is less than. There's no line there to make it equal to. Once again, I always test the point. 0, 0. Does 0, 0 work in this case? Let's find out. So 0, 0 is right here. Does it work? Actually, when I put it in, it does work. So I know that this part is a solution to the set. We know this is a solution. But then we test the point -2, 0, which is right here. And you're going to notice, oh, that does not make a true statement. So since 0, 0 works, we're going to shade that portion and know, okay, these guys, I'm going to use the highlighter here, these guys are solutions to this inequality. So once again, we're going to do many days of practice of this, so if it didn't really make sense to you, don't worry, we're going to have more lessons on it. But really go back and rewind the video if you need help. And remember, office hours are there for you to ask questions. Alright, thanks everybody, and I will see you for the next video.